Okay, so again, Unit 1, Notes 5, combining like terms. Starting off with vocabulary, we have the word term. Term is a number, variable, or product of numbers and variables. And remember, products are what? Answers to multiplication. So that means we could have a term that's just 7. Okay, we could have a term that is just the variable x. But we can also have the term that is 7 times x, the product, which is 7x. Okay, these are all examples of terms. Okay, then we have a coefficient. Coefficient is the number in front of a variable. Okay, so if I had the example of 8x, what is the coefficient? 8. That's the number in front of the variable, x. Okay, the next one is a constant. Okay, a constant is a term with no variable. So pretty much a coefficient that's by itself. So an example of a constant would just be a number. So like number 5 is an example of a constant. It's by itself. And then we have like terms. And these are terms that have the same variable and also raised to the same power. Okay, in like terms, I would say same variable, same power. That's the important part there. Okay, so the idea behind this is that in order to simplify our problem as much as we can, we're going to combine any like terms that we see. To combine like terms, we are going to add or subtract the coefficients and keep the variable the same. So I'm going to write that main idea here. So we add or subtract the coefficients and keep variables the same. Okay, so looking at some examples here, we are just going to identify if they are like terms or not like terms. So we have 3x and 8x. Thumbs up if they're like terms, thumbs down if they're not like terms. Okay, good. Thumbs up. They are like terms because they both have the same variable of x. So they are like terms, same x variable. Okay, what about 5x squared and 2x? Thumbs up for like terms or thumbs down for not like terms? Good, thumbs down. But why thumbs down? They both have x. Good, one has a power of 2. So remember, it's not only the same variables, but also the same power. So we would say not like terms because they have different powers. Okay, and then the last one here for this example is we have negative 4ab and 9ab. Thumbs up for like terms, thumbs down for not like terms. Okay, good. Thumbs up. Why thumbs up? Good. They both have AB. So they have the same AB variable. So what if one had A and the other had B? It wouldn't be like terms. What if one has A and the other one has AB? Or did I just say that? Okay. Then the other one has AB. Not the same. So even if they have one variable the same, they're not like terms unless they have all the variables the same. Okay, so now we're going to look at combining like terms. Okay, so now just not identifying if they're like terms, but actually combining them. So combining like terms. Examples. Okay, so example 1, we have 4x plus 7x. Okay, so first thing, are they like terms? Yes. So then we just add the coefficients. So what's 4 plus 7? 11. So the answer is 11x. Okay. Next one. 9m plus 4m. What would be the answer? 13m. We can combine the coefficients because they both have the variable of m. Okay, so now we're going to get a little harder. What if we had 6x plus 3 plus 2x plus 9? Are we able to combine all those numbers together? No, we have to identify the like terms. So what would be the like term for 6x? 2x. What would be the like term for 3? 9. So since I highlighted them in the same color, that's showing us that they are like terms. So I'm going to just combine the like terms. So 6x plus 2x is 8x, and 3 plus 9 is 12. So plus 12. That would be my answer. Okay, here's number 4. We have 7y plus 2 minus 3y plus 8. First, we need to identify which ones are like terms. So we have 7y and negative 3y. So notice I'm considering the negative with the coefficient. So anytime you see a negative, just attach it to the coefficient. Okay, and then we have 2 with 8. So 7y minus 3y becomes 4y. And 2 plus 8, 10. So that's our answer. Can I simplify that further? Can I add 4y to 10? No, because they're not like terms. Okay, let's look at the next one. 10a minus 3a plus 5 minus 8. Okay, go ahead and try that on your own. Give you 30 seconds. If you need to highlight or circle / box the like terms, I would do that. If not, you would just write your answer. So this one was nice and easy for us because they already put our like terms next to each other. So we had 10a minus 3a, which is 7a. And then 5 minus 8, which is negative 3. Can I combine 7a and negative 3? No. Okay. Go ahead and try this next one. 12x minus 5 minus 3x minus 9. Okay, so the important part here is that we always make the negative sign be attached to the coefficient. So for the first one, we have 12x minus 3x. What is that? 9x. And then we have negative 5. And then instead of saying minus 9, because that can get confusing, we could say negative 5 plus negative 9, which is going to be what? Negative 14. So if you get confused with the signs, you can simply think of it as adding since we attach the negative to the coefficient. Okay, so now we're going to add some more variables in here. So we have 3x squared plus 5x plus 4x squared minus 2x plus 7. Okay, so now instead of just 2 like terms, we have how many? 3 like terms. So we have 3x squared, which is going to go with 4x squared. We have 5x, which is going to go with negative 2x. And then what about that 7? It's just by itself. Okay, so when I combine them, 3x squared plus 4x squared is 7x squared. Notice the x squared didn't change, just the coefficient in the front. Then I have 5x minus 2x, which is 3x. And then what am I going to do with that plus 7? Just add it to the end. Okay, so can I combine or simplify my answer any further? No, because they're all different terms. Okay. Okay, here's 6n squared plus 2n plus 5n squared. Go ahead and take a moment and do that one. So for this one, are we combining all 3 of those numbers? No, because n squared is not the same as n. They're 2 different things. So what did you guys get? Go ahead and just shout your answer.
11n squared plus 2n.
Good. 11n squared plus 2n. 6n squared plus 5n squared became 11n squared, and the 2n was by itself, so we just attached it to the answer. Okay, so now the next part, a little note before we do the next problem, is what would we do if we see parentheses? So if there are parentheses, we must first distribute. Okay, so I'm going to draw my arrows telling me that I'm going to take that 2 and multiply it by every term on the inside. So I have 2 times x, which is 2x, and 2 times 3, which is 6. So that's plus 6 because that sign in between them was plus. And what do you think I'm going to do with that positive 5x? Add it to 2x, but first I'm just going to bring it down, okay, because I want everything on the same line. Okay, so good. I'm going to add it together because those are like terms. So I have 2x plus 5x, which is 7x. And then what am I going to do with that plus 6? Good, just attach it to my answer. Okay, go ahead and try this one. We have 4 parentheses a plus 2 plus 3a. Okay, so you first should have distributed the 4. And so that's 4 times a, which is 4a, plus 4 times 2, which is 8. And what are we doing with that plus 3a? We're going to bring it down and add it to what? The 4a. So 4a and 3a gives us 7a. And what are we doing with the plus 8? Add it to the end. Okay, what are you noticing when we do our answers? What comes first in our answer? The variable. Okay, so the variable comes first, then it's the constant value. Okay, also notice when we did this problem right here, we put our variables in order from greatest to least. So x squared is bigger than x. So that's why it came first. So I want you guys to get in the habit of putting them in order because that's going to help us when we get further along in the year. Any questions so far? Okay, let's do a couple word problems, some applications. Yes. Yes. Okay, so we have a teacher buys X packs of pencils in the morning and 3X packs in the evening. She already had 5 packs. Write and simplify the expression. Okay, expression means, are we solving? No, have we been solving here? Have we been saying A equals this, X equals this? No, we're just simplifying. Okay, so looking through here, the first thing I'm going to do is I'm going to highlight all the important information. So she buys X packs in the morning. She buys 3X packs in the evening. And she already had 5 packs. So what do you think we're going to do with each of these terms? Write them down and subtract them? Add them. So x plus 3x plus 5. Can we simplify that? What can we combine? Good. X and 3x, which becomes 4x. So 4x. And what about that plus 5? Just add it to the answer. Okay. This would be an example of if we're just simplifying an expression and we're not actually solving for x. Do you think I need to write a sentence? No. So later we will attach to this problem more scenarios. X is the following, okay, which means you'll be able to actually plug in a value for x and solve. Then I would need a sentence. Okay, one more. A side of a square is 5x minus 3. Write and simplify an expression representing the perimeter. Okay, so if we have a square, we know that the sides of a square are all equal. So if one side is 5x minus 3, what do you think the other sides are? 5x minus 3, 5x minus 3, 5x minus 3. So we could simply add all the sides together, okay? Or, since they are all the same value, we could take 5x minus 3 and multiply it by what? 4. So we could do 4 parentheses 5x minus 3. That tells us we are going to add those 4 sides all together. Okay. So since we have parentheses here, that tells us we're going to do what with the 4? Distribute. Good. We're going to use the math words. Distribute, which also means to multiply. And so what's 4 times 5x? 20x. And what's 4 times negative 3? Negative 12. Can we simplify that? Nope. So that is our answer.